Alrighty, good afternoon everyone. I understand it was a tough slot to choose a presentation of which one to go to. There's a couple of nice competing ones on, which I'd like to be at myself, but thank you for choosing this one. A little bit of context before we get into it. Feel free to ask questions along the way at any point. I much prefer to, like if you've got a question, other people are probably thinking the same thing, and much prefer to answer them as we go. And then what we're going to be going through today is looking at geolocation for a number of different ways. So we're going to be looking at some UX as we go. We're going to be looking at a few different APIs, some different formats, encodings, all sorts of things. So it'll be fairly blended as we go through, but a consistent story throughout. So the reason I wanted to do this talk was that quite often I'll see developers, I was always guilty of this as well, we'd say, okay, well, we've got a latitude and a longitude somewhere in there. Yep, geolocation, it's done. Users don't deal like that. Does anybody actually have any idea where negative 33,151 is? No. It's Sydney. It's where I live. So first of all, we've got a difference here between geodetic, which is the numbers, latitudes, longitudes, altitudes. That's geodetic. And then we have civic. So the other thing about location, though, is that these values like to change because people like to move, which gets very annoying when you're trying to write an application that does something with where they are. Out of that, we can also get a sense of a heading, which way they're going. We can get elevation, and we can get orientation. So orientation would be which way they're facing, heading is which way they're moving. So then we've got this number of different parameters here that we can work with. Every single one of these has a geodetic representation and then a civic representation. So all those values there are what we're going to get back from a sensor. But then, as far as the user's concerned, they want to see something like, I'm in Sydney, I'm on the second floor, heading to the city, driving, facing the ocean, or something like that. The second floor one there is a particularly interesting one. There's a lot of work going on at the moment around VoIP with emergency calling, like being able to pick up and dial 911. How does that actually get routed to the appropriate calling center in the first place? And one of the challenges they're working with there is that the type of data they're getting through in a lot of cases to be able to locate the phones gives them altitude, well, position geodetically, but then altitude also in meters. Whereas first of all, they need to get that into height above ground level, because it doesn't matter if you're 600 meters above sea level, and then also actually translate that into a floor so first responders can get to you and things like that. So some interesting challenges there. So then the way we convert between these is geocoding and reverse geocoding. So geocoding takes a civic representation, pushes it to geodetic. So when you type an address into Google, puts a push pin, reverse geocoding goes in the reverse. So running through all this pretty quickly so we can get into some code, and all very basic concepts, but I wanted to get the general ideas in there. The next question is, how can we go and get this information? And the most obvious one is GPS, except GPS is very expensive in terms of it takes a while to actually spin up, and then it also uses a lot of battery power, transmitters, and so on. So what actually happens in most of our cell phones is there's a technology called AGPS, which is assisted GPS. So normally, if you just have a standard GPS that you go and switch on, all the traditional ones, it takes about or up to 4 minutes to download enough information from the satellites to actually understand what's going on. Once it's warmed up and it has that information, it can then get a fix within a couple of seconds next time. So what your cell phone is doing is actually going out to the telco and getting that information back from the cell tower. That's how it's able to spin up so fast. We don't have a GPS in the device though. The next one is cell ID. So if we're working with 3G, 4G, any of those, all the cells you connect to have unique ID. You can triangulate based on that. We have databases that will help with that. Wi-Fi signatures, same sort of idea, but just using Wi-Fi signatures that are around you. So when the Google Maps cars went around and did all the photography for Street View, they were also actually recording all the Wi-Fi signatures they saw. So then if you can get a Wi-Fi footprint, give that up to Google, have a service, they can then go and give you back the latitude and longitude for where you currently are. We can then even take that just back to the network. So this is getting lower and lower quality information. So an IP address, look it up. Finally, you can just ask the user where they are. Very easily skipped over, but quite often people are happy to tell you. So let's jump into some code and see how some of this all links up. Sure. So the question was, is the Wi-Fi ID just the MAC address? Yes, the MAC address so is known as the physical address of the device it's used. And some of the databases that do it will also combine SSID so the network name, but obviously they can change. So what I've got here is a fairly simple page. First thing you'll notice is I'm using an HTML5 doc type. Everybody should be using this now. There's no reason not to. And then all I've got is just a link where I want to go and find the nearest store. So a fairly common scenario. And I'm just going to go and run this up in a browser. So we've got our link there. And the first thing I'm doing here from a development JavaScript point of view is I'm going to be using progressive enhancement. So that's a standard link. If the user doesn't have JavaScript, they click it. There we go. They click the link, and they're just going to go through to some other site. So in this case, I'm just feeding them through to Bing, but normally we'd just take them through to a list of all our stores. So let's make this more interesting, though. So the first thing I'm going to do is go and pull in it's probably the third time I've said the first thing I'm going to do. That's all right. So I'm going to go to the jQuery site and pull in a jQuery reference. The reason I'm actually showing you the way I'm doing this is you'll notice that there's the two different CDNs, the Google CDN, well, three, but the Google and the Microsoft CDN. If we use the link off the Microsoft CDN, you can see some of these links have little Visual Studio links next to them as well. So if I was to copy the Microsoft link, when Visual Studio gets around to downloading it. Okay. So one of the interesting things about if you reference jQuery off the Microsoft CDN instead of the Google CDN is you actually get all this Visual Studio IntelliSense documentation gets pulled in over the wire as well. Nice little feature that I just like to point out. All right, so the next thing I'm going to do is just when the document loads, we want to go and hook into when the user clicks on that link, right? So I'm going to give it an ID. Most people in the room familiar with jQuery? Yes? Awesome. I'm not going to explain jQuery stuff. So then because we're using progressive enhancement, we want to make sure that the default action for the link doesn't work. And then I'm just going to create a quick log function that is going to allow me to write out some log messages to that UL. All right, so they've gone and clicked the link. And I'm just going to say log searching. All right, so now I click it, that's what we get. So this is where we start to get into the browser APIs for geolocation. And it's actually really, really simple. So what we're doing here is we're going out to the browser, has a geolocation object. This is commonly referred to as part of HTML5, but it was originally a separate spec. And we have that whole nobody knows what's HTML5 and not anymore. So we can just pretend it is. We go out to it, we say we want to get the current position, and then we give it a callback. So it's totally asynchronous. It could take a minute until we get the location. We might never get it. It could time out, all sorts of things. So we just need to go and kick off that request and then continue doing things in our application. Then you'll see here in the callback, we get this location object, and I'm accessing the coordinates, so I'm asking for a geodetic representation. The spec does also handle civic information, and then I'm just going to go and log that out. So if I go and reload this page now, when I click this, the browser down the bottom is giving me a permission prompt that says localhost wants to track your physical location. and then I can just go and choose to allow that. And that's going to found my location. It's pretty simple, right? 3 lines of JavaScript. How many people knew that API existed? Not many. That's why you're here. Cool. For those that did know it exists, we're going to do some more fun with it. So the question was, in this case, how did it find the location? If I get rid of the dot there, I'll just show you the location it got. There we go. So it's put us on the green dot, which is pretty accurate in terms of Mandalay Bay. It's actually, there we go, just near the wave pool, so it's smack on. The way it's done it, I've got Fiddler running in the background here. And if we go up, here we go. There's a call here to inference.location.live.com, which then if we look in the inspectors, it's sending up an XML blob, yeah, so in the XML blob there, it's got all the Wi-Fi information. The signatures and stuff are embedded all the way scrolled across. It's gone up to a WCF service on live.com. They're then triangulating that based on what Wi-Fi signatures I can see and returning an XML blob with my lat, long, accuracy, and so on. In the case of the Internet Explorer implementation, they also actually send up your current time zone and a few other little things like that, just as validators to make sure they get you in roughly the right part of the world and stuff like that. So one of the things about this API is that the definition of it, the spec, purely describes how the API should work from a developer experience point of view. How it's implemented will vary to every single browser and client. All right, so we've got a really accurate location coming out of that, which is encouraging. So the other thing, though, is we need to go and handle cases where we can't find the location. So there's just a second callback for that. And one of these cases is, if I close and relaunch the browser, I go and hit it, I can choose to deny access. Caching error log sad face. Okay, let's play swap browsers. So here, you can see the user experience in Chrome is slightly different. If I go and deny that access, we get told about that straight away, so we can go and react. And I can then also go and get some extra information out of the actual error. So I can take error as an argument. And then there's 3 of these where we have timeout permission denied, which is where the user has actively said, no, I'm not going to give you that, and position unavailable, which is the user might have granted permission, but then we went off to try and find it, and we just couldn't get it. And we're always going to want to have a default case, just in case they add an extra error code. So if I go in here now, I'm actually getting denied. I can see the active reason why that's failed for that user. So leading into what browsers does this actually work in? What we're looking at here works in Internet Explorer 9, it works in Firefox, it works in Chrome, it works in Opera, it works in Safari. With the IE9 update for WinPhone 7, it will work there, it works in mobile Safari. Works basically in every single major browser that we currently have. Sorry, what was the question here? IE8? No, it doesn't, but we're going to get to that. Okay, IE8. Awesome that nobody asked about IE6. You just assume it's not there. What does anybody? Nobody just cares about IE6 anymore. We finally got rid of it. So leading into these error codes, next thing I'm going to do is also just pass in some extra config around. I can customize what I want the timeout to be. I can set a maximum age, so this is in seconds in terms of how long it's allowed to be from cache. And I can enable a mode called Enable High Accuracy. This has to be the worst possibly named parameter. What on earth does it mean? It's going to try harder to get a location, doesn't tell you what. It's completely undefined. It's just saying, please try harder. In general, you don't want to turn that on unless you actually find a scenario where you're not getting accurate enough location information for your application in whatever client you're using, because it's going to supposedly go out and use extra battery power or whatever, but it's not defined at all. And there's also an interesting little trick where with the timeout, if we want, we can actually set that to 0. So what this is going to do is it's going to say, it will give the user the permission prompt, but then it's going to look and it's only going to pull it back from cache if it's got a cached value within that maximum age. It's never even going to try to go and search for the location otherwise. So that can be useful as well if you just want to do a quick check, see if it's there already, but not care if it isn't. And then the final little bit of the signatures here is we're looking at get current position here, which just returns us a single hit. If we wanted to follow the user around, we could actually use watch position. And this works kind of like set timeout in that it returns an ID of the watch, and then you can clear that watch later as well if you want. And that's a lot more efficient than going and polling and constantly hitting trying to find it, because it'll just notify you when the user actually moves. All right, so IE8, what do we do? One of the really interesting things about this spec and why I really quite like it is that even when it wasn't in all the browsers, it was only in 1 or 2, it was still quite useful to go out and pick it up. Because it's not something like, say, SVG, where you really need it on all clients, otherwise you have to do a huge amount of fallback work or whatever, right? With this, even in the browsers where it does work, you're going to have scenarios where you can't go and get that location back, right? You're just not going to have the hardware to do it. So you're going to have to code a scenario that works with that anyway, where you let the user enter their location statically, or you just give them a list of all stores or something like that. The best part about being JavaScript, obviously, is that it's really easy for us to just go and detect whether it exists. So I can just say type of navigator.geolocation, and then that there we can just go and say no geo support. And the only browser on my machine where that will actually fail is IE6. But I have to spin up a whole VM for that. Okay, any questions on any of that? Oh, cool. Anybody seeing any uses for this in their applications? Mobile web stuff? The biggest area that I see is obviously mobile, where this is going to be really nice and useful. And it's sort of things like, there's so many different places where you could actually integrate this. You've got the simple example of stuff like Twitter or tagging photos or whatever else. But even in more sort of corporate scenarios, if I'm on a taxi website trying to book a taxi, why can't it try and get my address right first and then just let me enter it otherwise? Or if I'm on a movie website, just automatically show me the nearest cinema. Do something like that. Right. Just realized the sound guys asked me to turn my phone off, and I was about to show you a phone demo. So we have to wait for the phone to turn on. All right, so works absolutely everywhere. Okay, we'll jump across to some Windows 7 stuff quickly, actually. So one of the interesting things that showed up in the control panel in Windows 7 was a location and other sensors applet. So there's a whole sensor API built into Windows 7 which does stuff like tilt sensors and motion sensors and whatever in your laptop, but it also has all the support in there for location. And what's cool about this is that you can have a series of drivers that just plug into that generic location stack, and then applications can go and talk to them without having to go and understand what location providers you have. So a lot of the laptops that have integrated 3G modems in them these days actually also have integrated GPS chips as well. So then if you've got the drivers for them installed, it'll just show up in your location stack. Now, out of the box, it doesn't ship with any default providers or anything. It just has no way of providing location. But one of the ones that you can go and get and download just for free is called GeoSense. And what this does is installs a software-based driver that uses these same Wi-Fi signature services we've been looking at. So then what this allows me to do is, there's a demo there shipped with it. So this is just a .NET WinForms client. Okay, this is an interesting problem. So this is a .NET WinForms client, and it's gone out to the Windows 7 location stack. And we can see down the bottom, it puts a little systray icon in saying your location has been recently accessed. That's the operating system doing that. And then you can just access this from .NET code, native code, anything you want. I have absolutely no idea how it came up with that location, though. This is using the same service we were just looking at before. And one of the interesting uses for this from the operating system level is in your gadgets. If you drop the weather gadget on, you'll see there it's actually gone and automatically configured the weather gadget to that same location, albeit completely wrong. But it's going and using that infrastructure. Windows Live Photo Gallery also does the same thing. If we go into the control panel for this, one of the things that's hidden all the way down the bottom left-hand corner is this see also default location. And then this actually has config in here to enter my default location as well. I don't actually live there anymore, so don't send any gifts there. So here we've got a civic location that I can enter, and then you'll see it also has inputs for geodetic information, but it doesn't let you type them in through text boxes. You have to go and set that through the registry if you want. They figured that most users wouldn't actually be able to know what their latitude and longitude was and be able to type it in. So this is an interesting part of the operating system in that it's really well implemented and it's there and ready to go. Some applications are using it. If you're doing anything in Rich Client World, I'd encourage you to go and use this API. I'm personally a little bit disappointed that IE doesn't use this. I would have expected Internet Explorer to go and use it when they added support, because then that would have been a prime opportunity for them to have rolled out their own default software driver to everyone. Unfortunately, that wasn't the case, and I've yet to find out why. All right. Whenever you put in your tech requirements of what you need to do one of these talks, there's always all these extra checkboxes of do you need like device projectors and stuff. Then you actually tick them and it turns into this whole debate of whether or not you can get your hands on them. So we're going to use VLC in my webcam. What we can see here, very blurry, that's the same application that the same website that we just built, that HTML file. It's got the little link, find nearest store searching, and it pops up a prompt there of would like to use your location. So that works in the mobile scenario as well. Okay, so now I'm going to move away from web and we're going to jump across to Windows Phone 7. Is anybody in the room a Windows Phone 7 developer? Oh, couple. Web developers? Mostly web, okay. So in about 8 lines of code, if that, we can reproduce what we just built in the website. So I'm going to just add a list box, give it a name of status updates. And then if you want to get access to any of the geo functions, you have to add an extra reference to system.device. Same sort of concept of there's a watcher, and then it has an argument for it of geo position accuracy of default or high as well. Again, this isn't actually spec'd as to what that means. The idea is that the device will try harder. If you do any iOS development at all, they have a similar enum, but it has 5 different options, and they've actually spec'd it in terms of what they mean of if you choose this level, it's going to try and get it to street level, this level is going to try and get it to the actual house, that sort of stuff. And then there's just an event that we subscribe to. And then off the watcher, we can go and get the user's current position, or we can also get the status of the watcher. So a couple of interesting things to note here is that no matter where you create the watcher, whether you do it on a foreground or a background thread, it's always going to give you the callback on the UI thread. It's got the same idea of you can do a single hit or you can watch a position. And when you're watching a position, you can give it a threshold of how much you want the user to have moved by before it gives you a callback. Otherwise, in some cases, it's just, it seems to vary. Some developers find that it just gives you a callback about every second or so anyway, even if the user's not moving. Other people find that it has a default threshold. Go emulator. Okay. Anyway, when that comes up, it's not actually going to work. What it's going to say is that it doesn't have any data. The emulator, the current version of it, doesn't have a way of mocking the location at all. So it's just going to work in such a way that your application doesn't have access to that. So there are a number of blog posts up and frameworks out there to be able to mock that yourself, like switching your application into a mode where it just you have a static location configured. I missed one little step. So with the watcher here, you go and set up all of your subscriptions, and then you actually have to tell it to start. There we go. So it's gone initializing and then said no data as the status. All right, any questions on that? Nope, cool. Okay, if we jump back across to all right, so in terms of getting location, we've looked at JavaScript, we've looked at Windows 7. Windows Phone 7 stuff is obviously really, really easy, and there's the same support for native level code in both iOS. The Nokia stuff is actually really good. The Nokia browsers support the JavaScript APIs, not like from well before they were actually in any of the common browsers that we use on the desktop. And they've gone and documented all themselves. So it's not actually HTML5 geolocation, but they followed exactly the same API, sort of. So it all works. Okay, so how do we actually make this useful? We can go and get this latitude and longitude, and we'll go and get all these extra decimal places, but then it still doesn't mean anything to a user, because we want to go and turn that into something like Las Vegas. You'll notice when you tweet, it doesn't show the location, obviously. It'll say from Tathmodi at or in Las Vegas. Normally, though, when we go and do reverse geocoding, which would be the logical thing to do, we're going to go and get an address like this back, which is going to be really, really specific. So this is the idea of if we swap on to here, if we just zoom in on a random part of the States, there we go. And then if I go, what's here? Okay, all it did was find Kansas. Find somewhere that has population. I'm not from the US at all, so am I allowed to pay out people from Kansas? Okay, Google have gone and updated themselves. So normally if you go and say what's here, it would have gone and given you this really specific address. So we want something that's more contextually relevant to the user, though, to allow them to understand it. So let's have a look at ways that we can do that. So if we fire off our little geo service here, we can get the current latitude and longitude of where we are, and then let's go and convert this into something useful. Now, there's a data set that Yahoo released called WOEIDs, Where on Earth IDs, W-O-E-I-D, which is really quite useful. So I'm actually going to show you how that data set works, more from a concept. Well, A, it's a useful data set, but also just the concepts of how it works. There are other ones out there as well. So find the right version of Firefox. Okay, there we go. So we'll get to looking at the WOAD data set in a second. It's got its own API, which is quite interesting. It's up on where.yahoo.com. But one of the best places to actually get some of these location services is actually Flickr, because they've done a huge amount of work around making this useful for their photo experience. I never really thought previously of using the Flickr API to do any of this. So if I go, I'm just using the API tester here up on Flickr. And I'm just putting in the lat long that we found before. I go and trigger that method off. And it goes and gives us this result here. So it's gone and found a place that lat and long translates to. So it's got United States, Nevada, Las Vegas, Boulder Junction. But the interesting part there, as far as we're concerned, is actually this WOAD, W-O-E-I-D. So if we go and copy that number, I can then actually go across to the WOAD API. Now this is a REST-based API. So all I'm doing is v1 place and then just putting in that where on earth ID that we got, and then I've just got an app signature off the end. And this here is actually returning a whole bunch of information about the place it's found, obviously. So it's given us the suburb of Boulder Junction, and then a whole bunch of information about what it's in, and then also the bounding box for it. So if we look at the way Twitter handles their location, so here it says from Fisherman's Wharf, San Francisco, and you'll see that they're actually going, and not only are they putting my avatar where I actually sent that tweet from, but they're also highlighting the area because that's the area that they're describing. So for somebody who's just reading that stream of data, Fisherman's Wharf is the interesting part. So that's the type of information that we can get out of these. The other thing about WOADs, though, is that they exist in a tree. Every single WOAD has a parent so parents and children, they all get nested. So if I then, in the URL, because it's REST-based, I can say belong tos. So what other WOADs does this one belong to? And we can get a whole bunch of other places. So you'll see there's an entry for things like a zip code has its own entry, the town, the county, things like the time zone. There's a colloquial name for the area. So intermountain states, the time zone it's in, all this sort of information, which is really quite useful. So it's a really nice way in your application to be able to go and pick out these different types. So you could get that lat long and just say, oh, you're currently in the Great Basin area. One of the other things that this service does, though, is also actually helps us to understand sometimes what a user's typing in. So a whole bunch of common words that a user might turn into a search, put into a search, actually go and end up as all different types of place names. The French absolutely love to use English words as place names, or English love to use French place names as words. So then you've got stuff like Italy and all this sort of stuff. So how can we actually then go and contextualize our search as well? So in this API, it's Fiddler kicking off all those warnings. So I'm going to do another request here where I'm just going to say places, do a query. I'm going to search for, say, Long Beach. So it's found Long Beach, California, but one of the pet peeves for all of us who live down in places like Australia and New Zealand is every time we type in a place that's meant to be near us, it just goes and gives you like Long Beach, California. It's like, well, what if I want Long Beach in New Zealand? And it's given us that as the best possible match. But what I can do is, if I'd looked up a WOAD for where I currently was, I can provide that as some context. So if I add an extra ID in there as a filter, I can go and run that search in the context of that other location. So here it's then gone and found Long Beach in Otago, New Zealand. This is over on Flickr, the way they're doing their geo stuff. I quite like the actual way they've done the UI here around presenting this information as well. So Flickr's all based on words, so is Twitter. So here they've gone and found Sydney Central instead of just using the lat long. And then they've got this sort of zoomed out map, which is a country level. You can see sort of half of New Zealand in the corner. And then as I move my mouse in closer to the center, it actually goes through different zoom levels to give you the context of where you're in as well. Okay, so we've been able to find location. We can convert it between geodetic and civic. How can we actually go and share it around between applications? And geo is one of these areas that's actually really, really well spec'd out. There is a format for absolutely everything you want to do. There is absolutely no reason to find your own way to go and serialize or encode this information. So please don't. We've got HTML micro formats. So if we go across to our page we're working on. How many people are familiar with a micro format? A couple? All right. So if I went and said something like, I'm from, and I could say Sydney, there's no way for a browser to actually pop up and help the user in any way with that. But what I can do is if I put this in an abbreviation tag with a class of geo, and this is just a convention, I can then actually go and put a lat long against it. And what happens when I look at this in a browser? In this case here, I'm running, I've got the operator extension running in Firefox. You can see the word Sydney here has had it's showing up as an abbreviation, but operators lit it up and found it actually as a location. So we've been able to mark that up in our HTML in a way that I can then just go and say, oh, yep, just go and plot that on a map for me. And it'll go and search for that location. All right, other formats we've got are GeoRSS and GeoJSON. So these are extensions to, GeoRSS is an extension to RSS of extra elements that you can use against entries to mark their lat long, where they've come from. And you can go and produce this out of OData feeds and things like that as well. KML is another XML-based type, which is actually quite powerful. And it stands for Keyhole Markup Language. So Keyhole is what the name of the company was that built Google Earth before Google bought it. I get around and do a reasonable number of conferences and things like that. So to let people at home have a look and track where I am, I have a little service that I run, just tath.am/where. And what this goes and does is it actually produces a map of sort of the last 50-odd locations I've been as a series of dots that fade out over time. So if we zoom in here, we can see I obviously came through LA on the way over, and then I'm currently in Las Vegas, and it's got the time that I was there. So when I was building this service, I thought, okay, well, how am I actually going to get the data? I don't have to go and update it all the time. So I actually pull this off all my Twitter data. So just as I tweet around the place, updates the map automatically. And then I had to go and build a UI for it, and I really couldn't be bothered doing that. I wanted the smallest, simplest way to do it. So you'll see what's actually happened when I typed in tath.am/where is that I've just redirected across to Google Maps and then just passed in as the search term a link to this KML file. If we save this down, so KML not only allows us to go and feed back a series of points, you can do shapes, polygons, lines, paths, all that sort of stuff, but we can also hand back style information with it as well. So what I've got here is I'm feeding back a place mark at a particular coordinate, and then I'm able to go and give style information against it that then tells it a specific icon to use. So those fading little white icons that are getting plotted straight on maps.google.com actually come from my server, and I can send that information down. What's cool about this format is not only can I go and put it into a web-based environment, but if I actually went and just open that KML file on my machine, we go and get to see where I've been in 3D. And interestingly, about half the time when I show this, it seems to zoom in on Africa. No, we're not there. Okay, so it's sort of averaging out between Sydney and LA. There we go. So we can see those points there getting pulled in as well. So pretty powerful in terms of how we can just take that data and open it up in multiple clients. KML is actually supported by Bing Maps as well, however, only at the API level. So if you're using the Bing Maps JavaScript API, you can say and go and add a layer from KML, and that'll work. The reason I use Google Maps for this is that I can just put it into the search box, and it will just detect that it's KML. EXIF data. Any photographers in the room who know what EXIF is? Cool. So if we go and look at something like photos off my phone, we look in the properties for these. So I'm just looking at the file properties. I haven't pulled it in. So we get all the information in here about what sort of focus and white balance mode and everything was used. This is embedded in the JPEG. But there's actually also fields in there for embedding information about where the photo was taken. Every photo you take on an iPhone gets this information tagged. I'm not sure about Windows Phone 7. I haven't had a look. So then if I was to go and upload this photo to Flickr, they can go and extract all that information automatically, just read it straight out of the file. And Windows Live Photo Gallery does this really well, where it's going and pulling all that information, doing the civic lookups for them, and then actually grouping my photos by location. So I can go and just search by suburb for where I took a photo. ICBM meta tags aren't really used anymore, but just a sense of there's a solution for everything. There's actually a series of meta tags that you can put in the head section of your page if you want, that describe where that page relates to. So say you're building a small business listing site or something, for each of those result pages, you'd go and include that information in the head so that then other crawlers can go and get that information. They're quite an old concept that didn't really take off, but if you wanted to tag pages, that's the way you do it. And there's even a way at DNS level where, in the same way you've got A records and C names and things, there's actually a lock record for specifying the location down there. So there's absolutely a way to solve every single encoding you want. All right, so what we've gone through today is had a look at what is location in terms of geodetic versus civic. We've looked at ways of actually finding it between browsers, native devices, and in the operating system. Talked a little bit about how to make it useful in terms of making it contextual to the user, and then also ways of sharing that between your applications. The key takeaways that I want you to think about is that you can go and use this now in terms of, yes, it is in all the latest browsers, but where it's not in browsers like IE8 and things like that, you're still going to have to code for that scenario to handle you can't get the location, or you did get it and it's not accurate, or the user don't want to provide you with automated access to that anyway. So you're still going to cover those scenarios. And in that sense there, it's all ready to go right now. So it's just a nice value add in a lot of different scenarios. So with that, thanks for coming along. I'll hang around, and if there's any questions now, open them up. Thank you. And all the resources are up there. Sure.
What do you think that the GeoNames repository is compared to Yahoo?
So GeoNames versus Yahoo. The thing I like about Yahoo is that it's got that tree-based structure, which I think is a bit easier to walk than last time I looked at GeoNames. It's okay. I wasn't familiar with what they did. Okay, so the same sort of concept then. I think they do. If you supply a callback parameter, yes, you can get JSON back from it. Yeah.
So short path to get to the actual information from Yahoo without going on Flickr?
No, that's actually, so the Flickr API is actually the best way to find the where on earth IDs, I find. But it's the same company anyway, that all they've done is just split the API up into some nasty places. I don't know of JavaScript libraries. I generally want to do this sort of stuff on the server because where you do have any of those multiple callbacks and stuff, it's just easy to do it up there. So yeah, I do it up there. Yeah. No, all this stuff's all pretty easy to query. I normally just do it directly. But yeah. Cool. Yeah, so all the code from the demos is up there, and the link to the Ware service is up. Oh, the Ware service code is up on GitHub if you want to get that at all. Except it runs in Rails on Heroku. Cool. Flickr is definitely pretty solid, and that's ready for commercial use. The Where on Earth ID dataset is what Twitter used to generate all their trend data.
Okay.
So yeah, the dataset's good to go. So, yeah. Right. So yeah, the prompt, you would get one for each domain because they have to be each approved or denied. You can, GeoJSON, you can only represent points and polygons and stuff. You can't send the style information down with them. KML is kind of, it really is more of a markup language as well. So GeoJSON is just a raw data transfer. Yeah. Sure. I don't think they are. I think Facebook location IDs are their own little invention. Not that I know of at this time. The driver is geosense4windows.com. Yep. Awesome. Thanks. Which one, sorry? Oh, that was just the Twitter webpage. Yes, if you're calling the Twitter API and you get the blob back, we'll give you the Twitter place ID. I think you'll have to do a separate call to get the actual polygon, potentially. Yeah, you certainly can. The Twitter for iPhone client renders the polygons and stuff as well, and they use the same public API.